Hello, welcome to another episode of Tech Flourishing. So today's episode is going to be pretty broad. I'm talking generally about statistics, which is a vast subject, I know, but I wanted to just really hammer home, I suppose, how important I've found knowing various aspects of statistics through my career in, I suppose, what now people call STEM disciplines. I was just trying to think before I started this episode if there was one discipline which I have used again and again in multiple different domains in, within diagnostics, within teaching, within management information systems, accounting systems, support, training, all the different things I've been involved with over the years. Probably statistics is up there. So I figured I should do an episode about this. It's going to be a whistle-stop tour, and I'll just highlight as I go through the tabs here why they're relevant to various aspects of my life, I suppose, generally. When they occurred, there's obviously bits I'm probably going to skip over and I'll just try and line this up so there is some thread running through this. So I include the first couple of tabs here, history of statistics, and there's a really interesting timeline of probability and statistics. These are great, starting points if you like, and then you can just expand out from there. I was trying to think, what was the first statistical technique that I used? It was probably histograms. That was the first thing that I remember learning at school, was creating histograms, invariably from, I think they were called tally sheets. So if you turned a tally sheet on its side, if it was like grouped data you were tallying, it would look very much like a histogram. Now there is a difference here between histograms and bar charts as well. And again, it's a lot to do with the type of data that you're plotting. So with histograms, we're talking about continuous data where the bins represent ranges of data, whereas a bar chart is a plot of categorical variables, like categories of things. But yeah, it can get very blurry. But certainly that's where I started off at school, learning about histograms, drawing histograms, drawing as well bar charts, because we would have been dealing with both continuous data and categorical variables. And actually, I don't remember specifically learning it at that point, but when you do start to go down the statistics rabbit hole, you do spend a little bit of time learning about, continuous versus discrete, and all various other ways of defining types of data, and also ways of dividing the bins up as well. And I'll be revisiting this later in the episode, actually. So that was my first exposure with histograms, and it sort of expanded out from there. then went on to things like descriptive statistics. So these are measures of central tendency, or variability or dispersion. So mean, median, mode, standard deviation. I got really interested in the shape of distributions, and things like kurtosis and skewness as well, and the various calculations for working those out. And so that was something else I did when I was, junior school, secondary school. It got revisited when I did computer studies. We were learning about things like statistical inference and, related probabilistic techniques. And again, with statistical inference, I found that I was revisiting it later on when I explored things like machine learning and data science and stuff like that. So no doubt this will get flagged up again in a moment. When I started going to college and having to analyse, I suppose, trials, as in trials related to antibiotics or drugs, then I got much more exposed to things like t-distributions, these sort of things like t-tests, and various other types of tests as well, other statistical tests beyond the previously mentioned descriptive statistics. So that was probably my next exposure. So the range of things that I could do within statistics was constantly expanding between the ages of, say, 7 and into my early 20s. And as I moved from working in, I suppose, immunology and moved over to more working in quality control, this sort of stuff was still important, but then I got more exposed to sampling statistics as well, and various sampling methods that we would use, and as well revisiting other ways in which to compare data using graphs. So there was instances where things like alongside the sampling statistics, I remember doing a lot of line of best fit stuff as well. And then I started to get involved a lot more in numerical taxonomy, which relies very heavily, or aspects of it rely very heavily on probability. And, a lot of the probability that I'd learnt in math and statistics at school, and I don't know if I mentioned it at the start here when I was talking about learning statistics, but I did a whole year of a statistics course between the age of 16 and 17, which really provided me with a good foundation for all the statistics I subsequently did. I think without that I would have found things a lot harder. So when I was finally exposed to the ins and outs of numerical taxonomy and things like taxonomic distance and other calculations, it was a lot easier to understand. Working in quality, I got re-exposed to histograms through the 7 basic tools of quality, also things like scatter diagrams, stratifications, run charts. I've got here control charts, those sort of things. And yeah, I can remember it was actually probably just before I became aware of the 7 basic tools of quality. I remember having to do linear regression again at college on several occasions for forecasting reasons. And again, it's interesting how these things serve you on a go-forward basis, because things I learnt when I learnt linear regression also were very useful when I visited sort of data science as a discipline, which we'll get on to in a moment. Now, sometime around when I was playing around with linear regression and the whole numerical taxonomy thing, I was first introduced to artificial neural networks. Now, I didn't go down that particular rabbit hole at the time, and at that point the neural networks I saw being written about were actually hardware based. For some reason, from what I remember, is that the software that was available, or the computers that were available, weren't really fast enough to do the sort of calculations required, and there was a lot of reliance on special hardware, especially sort of programmed hardware, to do the heavy lifting. So I took a look at it because I was interested in how it might be used as an alternative to doing, numerical taxonomy, using a lot of the programs that I think that Sneath had put together. And so I was curious, but I didn't really have enough time to spend on this. And this would have been probably sometime in maybe the late 80s, I think. Eventually, when I left biological science and moved more into pure computing and support, ultimately I ended up teaching for a while in management information systems, because I had experience of working on accounting systems and management information systems through working for a value-added reseller. And a lot of stuff I'd previously learned in statistics again came up, because the management information systems that I was working with and I was talking to students about, contained elements within them that utilize statistical functions. Things like decision support systems. And I'd worked in decision support systems before, but at that point when I was doing it, a lot of it was just straight yes-no rules-based stuff. So it was interesting to see how much decision support systems, executive support systems had moved on, because as computing power had advanced, the sort of operations that you wanted to do became more accessible to the desktop. So we're probably talking about somewhere here in the 90s when I first really got exposed to MIS. Now, bubbling in the background, all from early 90s, I suppose. I'm just trying to think when I first got my first books. Actually, no, 94 was my use of spreadsheets. And that probably started off with SuperCalc. I did dabble a bit with Lotus 123, but not so much. But yeah, mostly SuperCalc, and then ultimately Microsoft Excel. So previously, when I'd had to write programs to do statistical analysis. What was great was now that spreadsheets could do them, and on the platforms, that I was running them on. So we would have been into the era of Windows 95 onwards, probably. I had used, I think, Lotus 123 in DOS, maybe. But SuperCalc and Excel I was certainly, using on the Windows platforms. And of course, at that time, computers were getting much faster. And I don't know if anybody remembers, but in the early days of spreadsheets, you'd often leave it and wouldn't be doing the calculations on the fly. So I can't remember whether it was the F5 key to do a refresh, but you wouldn't have auto refresh on, because it used to be able to see the lag on the spreadsheet as it was calculating as you changed values. So often that might get switched off, and then you'd have to remember to press F5 or whatever the key was at that time to refresh it. Sometime I would say, so that really, all of those elements were coming together in different different components, different domains, all through the late 90s into the 2000s, into the 2010s, where I was just doing variations on that in the various areas I found myself, like working with different clients who had different needs all through the 2000s into the 2010s. When I went back to working for a firm, and I was involved more with day-to-day support and how to use spreadsheets day to day, and doing training in spreadsheet work and various other advanced features as well. There's a number of calculations you can do in, say, Word and those sort of areas. But I got interested in data science and did a series of courses with Microsoft, and so that basically updated a certain aspect or collated a certain aspect of my knowledge, so that in the early 2010s through to about 2015, I was a bit more actively engaged in the discipline of data science and exploring it through those courses. And so through the courses I revisited Microsoft. Well, I was doing Microsoft Excel all the time, but expanded my knowledge of Microsoft Excel and what it was capable of doing, now in terms of the 2010s compared, or when I say now, now at that point in 2010 compared to, say, when I was interacting with databases in the 80s or the 90s. And the whole range of data tools that you had accessible in Excel. Alongside that, all the stuff that's available in Python for statistics, and also, it's important from the back end, from where the data's coming from. So understanding how to do queries. So that all bundled up into a sort of nice, neat package. And, I'd learnt about relational database management systems to a fairly high level back in the early 90s when I did my postgrad, and there was a whole unit on relational database management systems, and we had to learn SQL. And I revisited SQL at various points as well through other courses, but certainly having a good understanding of query languages for databases is obviously key for modern statistics, because more and more you might be finding yourself interacting with like back-end systems in some capacity. And it was sort of exposed through that I found myself also exposed to Power BI, related to some stats we were running monthly at work to do with the usage that end users were with relating to a certain archiving system that we were using, and I was sort of collecting together those stats and presenting them, and I was actually using a sort of mashup of SQL, Microsoft Power BI and Excel as well. And then something else I've found, which statistics have played a really important part in terms of, like, again, collecting data to use the stats, and that's understanding APIs. I find often now when I'm using APIs, there's a statistical element within there that I might be performing after I've pulled the data down. And so, yeah, that also impacts on it as well. But what's nice about APIs is there's so many libraries now in Python that enable you to interact with an API very cleanly in order to access certain, data. So, a lot of the major platforms on the web have particular APIs. I've spoken about Spotify in the past, and Last.fm is another one. Wikipedia, those sort of things. They all have APIs, and you can use that to obviously ingress data and manipulate it in certain ways, some of which will, involve statistical analysis. So hopefully that's been useful. Me just talking about generally how I found, a good statistical foundation to be really critical in all the different aspects of STEM that I've done over the years. And certainly I find it very difficult to imagine what my academic and career life would be like without a good understanding of statistics and all the other disciplines and domains that exist alongside it. So thanks once again for watching. I'll include all the tabs as links in the description. So bye for now, and I will catch you in the next episode.